Welcome to the Walton Pi. Today we're going to be talking about derivatives of trig functions. So to find the derivatives of all the trig functions, we're going to have to accept two derivatives without proof. So we're just going to have to accept that the derivative of sine of x is equal to cosine of x, and the derivative of cosine of x is equal to sine of x. These are true facts, but the proofs are a bit complicated, so I'm not going to go into them in this video. I might make a video on it later, but at the moment I am not planning on it, so we are just going to accept that the derivative of sine of x is cosine of x, and the derivative of cosine of x is negative sine of x. So if we want to find the derivative of tangent of x, we're going to be using the quotient rule to do this. So the tangent of x can be rewritten as sine of x over cosine of x, so we can now use the quotient rule to find the derivative of that. It's going to be cosine of x times the derivative of sine of x minus sine of x times the derivative of cosine of x all over cosine squared of x. So low d high minus high d low all over the bottom squared. It's going to be the same pattern every single time we take the quotient rule. So if we evaluate what derivative of sine and derivative of cosine are, we're going to get cosine of x times cosine of x minus sine of x times negative sine of x all over cosine squared. Well, that becomes cosine squared x plus sine squared x all over cosine squared x, and cosine squared plus sine squared is just 1, so we get 1 over cosine squared of x, or secant squared of x. So that tells us that the derivative of tangent is secant squared. To figure out the derivative of cotangent, we are also going to be using the quotient rule. So cotangent is cosine over sine, so that's going to give us sine times the derivative of cosine minus cosine times the derivative of sine all over sine squared. So low d high minus high d low, square the bottom, and off we go. We have exactly what we need to be able to figure it out. So plugging in the derivatives of cosine and sine, we get sine of x times negative sine of x minus cosine of x times cosine of x all over sine squared of x. So that's a negative sine squared of x minus cosine squared of x all over sine squared of x, or negative 1 over sine squared, which is negative cosecant squared. To find the derivative of secant, that's just 1 over cosine. So then we have our quotient rule, derivative cosine of x times the derivative of 1, minus 1 times the derivative of cosine, all over cosine squared. That gives us 0 minus 1 times negative sine of x, or just sine x over cosine squared of x, which is 1 over cosine times sine over cosine, or secant of x tangent of x. And then the derivative of cosecant of x, we are going to use the quotient rule again. Cosecant is 1 over sine, so that gives us sine of x times the derivative of 1, minus 1 times the derivative of sine, all over sine squared. That gives us 0 minus cosine of x over sine squared of x, or negative 1 over sine of x times cosine of x sine of x, or negative cosecant of x cotangent of x. So here's a quick summary of all 6 derivatives. The derivative of sine is cosine, the derivative of cosine is negative sine, derivative of tangent is secant squared, the derivative of cotangent is negative cosecant squared, the derivative of secant is secant times tangent, derivative of cosecant is negative cosecant times cotangent. So those are just what all of those different derivatives are going to be. I hope this video was helpful. Please like and subscribe if you haven't already so that I can continue to make these sorts of videos. Have a great day and good luck with the rest of your math.